Introduction to Engineering Mechanics. Content covered. Definition of mechanics with importance. Historical development in mechanics. Brief classification of mechanics. Definition of engineering mechanics with static and dynamics. Definition of mechanics of materials, SOM. Definition of fluid mechanics, FM. What is mechanics? Mechanics is the physical science which deals with the effects of forces on objects. The purpose of mechanics is to explain and predict physical phenomena and thus to lay the foundation for engineering applications. Although the principles of mechanics are few, they have wide application in engineering. The principles of mechanics are central to research and development in the fields of vibrations, stability, and strength of structures and machines, robotics, rocket and spacecraft design, automatic control, engine performance, fluid flow, electrical machines, molecular, atomic, and subatomic behavior. Historical development in mechanics. Mechanics is the oldest of the physical sciences. The early history of this subject is synonymous with the very beginnings of engineering. The earliest recorded writings in mechanics are those of Archimedes, 287 to 212 BC, on the principle of the lever and the principle of buoyancy. According to Archimedes' principle, the buoyant force exerted on the object is equal to the weight of the fluid it displaces. Buoyancy explains both how a ship floats on water, and how a balloon floats in the air. The pressures of water at the bottom of the ocean, and of air at the surface of Earth, are both examples of hydrostatic pressure. The subject of statics developed very early in history because its principles can be formulated simply from measurements of geometry and force. Substantial progress came later with the formulation of the laws of vector combination of forces by Simon Stevin, also known as Stevinus, 1548 to 1620, who also formulated most of the principles of statics. Since the principles of dynamics depend on an accurate measurement of time, this subject developed much later. Galileo Galilei, 1564 to 1642, was one of the first major contributors to this field. His work consisted of experiments using pendulums and falling bodies. The most significant contributions in dynamics, however, were made by Isaac Newton, 1642 to 1727, who is noted for his formulation of the three fundamental laws of motion and the law of universal gravitational attraction. Substantial contributions to the development of mechanics were also made by Da Vinci, Varignon, Euler, D'Alembert, Lagrange, Laplace, and others. Classification of engineering mechanics. In general, this subject can be subdivided into three branches: rigid body mechanics, deformable body mechanics, and fluid mechanics. Rigid body mechanics is a branch of the physical sciences that is concerned with the state of rest or motion of rigid bodies that are subjected to the action of forces. In this type, deformation of the body under the action of force is neglected. Rigid body mechanics is divided into two areas: statics and dynamics. Statics deals with the equilibrium of bodies, that is, those that are either at rest or move with a constant velocity, whereas dynamics is concerned with the accelerated motion of bodies. We can consider statics as a special case of dynamics, in which the acceleration is zero. However, statics deserves separate treatment in engineering education since many objects are designed with the intention that they remain in equilibrium. Rigid body mechanics, frequently called as engineering mechanics or vector mechanics. Dynamics is further classified into kinematics and kinetics. Kinematics, it is branch of dynamics, which deals only with the bodies under motion without considering the forces causing the motion. Kinetics, it is branch of dynamics, which deals with motion caused due to forces acting on the body. Another branch of mechanics is deformable body mechanics, which concerned with the deformation caused in the body due to application of external force. To understand the deformable body mechanics, it is prerequisite to understand the rigid body mechanics as the design and analysis of many types of structural members and mechanical components require force analysis. This study is frequently called as mechanics of material or strength of material. Fluid mechanics is the branch of physics concerned with the mechanics of fluids and the forces on them. The term fluid in everyday language typically refers only to liquids, but in the realm of physics, fluid describes any gas or liquid that conforms to the shape of its container. This area of physics is divided into fluid statics, the study of the behavior of stationary fluids, and fluid dynamics, the study of the behavior of moving or flowing fluids. Fluid dynamics is further divided into hydrodynamics, or the study of water flow, and aerodynamics, the study of airflow. Applications of fluid mechanics include a variety of machines, ranging from the water wheel to the airplane. Rigid body mechanics, frequently called engineering mechanics, is the primary requirement to learn other forms of mechanics.